Alright, because of the limitations on uploading videos on YouTube, this is just a separate sort of video. But don't worry, I'm still gonna upload another lecture. Alright, so in the previous lecture, we picked us a problem, notably problem number 8 in page 66, chapter 4. Wherein we are given the condition that within 10 seconds, half of the population has already been converted into femboys, and now we want to find out when 9/10 of the population turns into the femboys. So we're given a timeline. So within 10 seconds, half turns into femboys. We need to find out when 9/10 of the population becomes femboys. So break up my calculator. Alright, calculator. I don't use graphing calculators because I really don't use them. So 9/10 is approximately 0.9. So 90% of the population. So since 1/2 is half the population, at a certain time t, it's already around 90%. 90% of the population. So this is 50%, this one's 90% of the population. So at 10 seconds, 50% of the population has been converted into femboys. And here, we're trying to find the t seconds wherein 90% of the population, or a majority of them, has been converted. So I'm going to list it down over here. This p is a function of time. P dot is equal to negative k p. Alright? Or actually rho. But I'm going to use p here. I'm just gonna write here. P of t is equal to rho a while ago, okay? And so our law applies. So let's say that we have a population of 100. I mentioned in the other video, 100 individuals. So we have 100 individuals at that. P can actually be an arbitrary value, but to make things computationally easy, I'm gonna pick P is 100 individuals at the start. So at 0 seconds, it's 100 individuals. At so P. So now we can set up our boundary problem. So at 10 seconds, at t equals 10 seconds, P is 50 individuals. And at t equals, we don't know, P is 90 individuals. Individuals. Now we gotta find that t. So given these initial conditions. Now we know the solution to be P equals C e to the negative kt. Alright. So let's find C here, right? And let's say we're given a constant K. I wonder if, let me check if it's right. There's actually a constant. I don't think they really, wait, sorry for a little buffer. I need a little buffer. Alright, so we're given, so 9/10 of this population is converted, right? So I want you guys to take note of this 9/10 of P. So after 10 seconds, 1/2 is converted. And here this time, in question seconds or unknown seconds, 9/10 of that initial population is already converted here. So this is essentially, we can convert this equation into 9/10 P equals P e to the negative kt, and so we can find k from there. So 9/10. Sorry for the music. People play music in the background, right there, especially the workers. So our initial condition is 100, so it's 90, and our initial population here is actually hold on. our initial population is 100. E to the negative kt. So we're trying to find k, and this is at t equals 10 seconds. So we can just do some, take 90, 100, e to the negative k times 10, and so divide both sides by 100, 100, and that's 90 over 100. That's still 0.9. 0.9. I'm gonna move it here. Alright. Equals e to the negative k10. And the ln of 0.9 is negative 0.11 approximately. Equal negative k10. And so just divide both sides by 10. And so that's divided by 10. And we get negative 0.01 equals negative k, and k is 0.01. K is 0.01. And now from there, we can hit rewind. We can hit rewind and find p at our initial thingy t here. So at t, we're trying to find t given our population. So this time, let me just erase that. Alright, we already know this is individual, I can erase that. So that's 90 equals our initial population 100. E to the negative 0.01 times t. And so just so that's 0.9. 9 divided by 100 is 0.9 equals e to negative 0.01 times t. Take the ln of both sides. So just take the ln of both sides and equals 0.01 t. So the ln of 0.9 is 0.11, negative 0.11 equals negative 0.01 e divided by negative 0.01 divided by 0.11 divided by 0.01 is 11. So now our conclusion is that 9/10 of the population has been converted at f at 11 seconds, given a conversion factor of 0.01. And so that's it for this lecture. In the next lecture, I'm going to be discussing conversion armaments 2, wherein we use some logistic growth or through some process, the growth of femboys in the population, or conversion of growth of a population, like a bunch of femboys in a null population, increases logistically. We're gonna do some problems then. So then I'll see you guys in the next lecture.